Best way to practice this problem for optimization, make sure you pause the video and do it on your own, and then you can compare after. Okay, so let's do number one. A company has started selling a new type of smartphone at the price of, this is the price of cell phone. X is a number of smartphones manufactured per day. The parts for each smartphone cost $50. The labor and overhead for running the plant cost $6,000 per day. So how many smartphones should the company manufacture and sell per day? Maximize the profit. And they gave you what is the profit. Profit is revenue minus cost. Okay. So you can make an equation. So let's say profit is in terms of X, profit X. And then what is then revenue? Revenue means the money coming in by selling the smartphone. Okay. And then they gave you this expression here. That's the price, right? The selling price of phone. So you can say 110 minus 0.05x. That's each phone they're gonna get it. So times x means a total amount of money coming in by selling it. Minus, and the cost is said that each one is a $50 cost, right? So 50x minus, and then also this one is a labor and overhead for per day 6,000. So that equation stands for, so this is a revenue and this one is cost. Okay, then that's the profit. So let's talk about domain. Domain is for x value. X is said that the number of smartphones. So of course should be greater than equal 0. Okay, and let's just simplify before you take a derivative. So when you simplify, negative 0.05x squared plus 110x when you distribute this, minus 50x minus 6,000. Now when you collect them here, negative 0.05x squared plus 60x minus 6,000. So to find out maximum minimum, you have to always take a derivative to find out critical value. So let's go ahead and take a derivative. Then you get negative 0.10x plus 60, and then set equal 0, and then you need to solve for x, right, to find that critical value. So 0.10x equals 60, so x is 60 divided by 0.1, which is a 600. So 600 units you need to make in order to make a maximum. But to justify actually the maximum, you can do first derivative test or second derivative test. It's up to you. So when you take a derivative this one, let's say second derivative test, when you take a derivative one more time, then you get negative 0.10. Okay, so that means always a concave down. So concave down, then you have that critical value is only 1. So that means that's a max. It shows a max. Okay, or you can do first derivative test if you want. P prime of x, and right here is a 600, and then you use this equation right here. Okay, because that's a p prime of x. So when you plug in greater than 600, then you're gonna get a negative value, and then if it's less than 600, that's a positive. So going up, going down. So this one shows it has a max. Okay, so either way, you can do second derivative test or first derivative test. Now, so yeah, that's the answer. So how many cell phone? You need to make 600 to make a maximum profit. Now, number 2, renter wants to construct 2 identical rectangular quarters using 200 feet of fencing. Okay, 200 feet of fencing. The renter decide to build them adjacent to each other, so they share fencing on one side. So what dimension should the renter use to construct each quarter so that together they will enclose the largest possible maximum area. Okay, let's draw a diagram. So you have a coral, two corals right next to each other, and they share fencing one side like there. And then let's label it for my convenience. Let's say this on y and this on x. Then of course each one is x and this side also y. And they said 200 feet fencing. So 200 equals 3x plus 2y. So entire the length is that 200 feet fencing. Now area is length times width. So this length times width is area of this whole thing, right? So then x times y. So you need to isolate one of the variable from the here, and then you can substitute. So let's isolate y. So 2y equals 200 minus 3x. And when you divide by 2, so y equals 100 minus 1.5x. Okay, 3 divided by 2 is 1.5. So you can substitute. So I'm going to say a of x now, because only variable is x. After you substitute, 100 minus 1.5 x squared. So when you put in order, I mean, that one is x, actually. And then negative 1.5 x squared plus 100x. So again, next procedure, always take a derivative in order to find the critical value. So when you take a derivative first term, negative 3.0x plus 100. And then you need to set equal 0 to find the critical value. So 3.0x equals 100. Okay, then x is 100 over 3. 100 over 3 feet. Okay, so but you need to show that one is actually make a largest area. So you can do also second derivative test. So that's a negative 3.0. Okay, second derivative is a negative, means always a negative, means it's always concave down. So that 1 point is a max. Okay, you can show, or you can do first derivative test, 100 over 3. So you pick. Let's talk about domain first. Okay, before I forget. Then your x value should be greater than 0. Okay, it cannot be negative or 0. But of course, x cannot be over 200 because entire fence is 200. So that's the domain. So in this domain, you can pick any value like 10, and here any value that's a greater than 30. So let's say like 50 example. Then you're gonna get plus minus. Okay, so that means going up, going down. So you're gonna have max. You can do first derivative test too. Okay, either way, first derivative test or second derivative test. And then after that, so I got this one is a maximum. And they ask you what is the dimensions. Okay, so x is right here, 100 over 3 feet. Now what about y? Y you can use it here. So 100 minus 1.5, or you can say 3 half times 100 over 3. So 3 half, 3 cancel. So that's 100 minus 50. That's 50 feet. So this one is 50 feet. Okay. So 100 over 3 by 50 feet. Then you're gonna get maximum area. Okay. Number 3, a cryptography expert is deciphering computer code. To do this, the expert needs to minimize the product of the positive rational number, okay, negative rational number, to minimize the product, given that the positive number is exactly 8 greater than the negative number. And then what final product is expert looking for? Okay, let's for my convenience, positive rational number x, this one is y. Okay, so product is x times y. And then what is said is positive number, which is x, is exactly 8 greater than y value. So y plus 8. So you can substitute. It already isolate x value, so you can make it in terms of y. Doesn't matter if you want, you can make it in terms of x or in terms of y. So y plus 8 times y. So y squared plus 8y. when you distribute. Now, of course, next step is you need to take a derivative to find the critical value. 2y plus 8. So set equal 0. So 2y equals negative 8. Y is a negative 4. Okay, so that makes sense. Y was a negative. Okay, y was a negative. But how do you know that one is basically minimum product, right? So p prime negative 4, right? And then your domain y value, because we talk about only y value, so should be less than 0 because y is a negative rational number. So let's say the bigger one is a negative 3 and negative 5. So when you do test, it's negative and positive, so going down, going up. So you have a minimum. Okay, you can make sure you plug in here. So then, now question is, what final product is the expert looking for? So that time your x value is negative 4 plus 8 is a 4. So your product is x times y. 4 times negative 4, so negative 16. So that's the minimum product. Okay, that's fine answer. Number 4, I'm gonna skip because that's basically the same thing as the other one. Number 5. Okay, let's look at number 5. Engineers are designing a box-shaped aquarium with a square bottom and open top. So let me quickly sketch aquarium. So you have square on the bottom, right? Let's label it here XX, and this is Y. And here is open top. Okay. And then volume is this one. Now, what dimension should they use to create the acceptable aquarium with least amount of glass? Okay. So least amount of glass is means what is the smallest least surface area. So you're looking for least surface area. Okay, so let's area is basically you have only one bottom, right, square, and this area here is xy, but all the way around you have a 4, so 4xy. Okay, now what we know is they gave you volume, so volume of that rectangular solid is x squared times y, that is a 500. So I'm going to isolate y. Y equals a 500 over x squared. So you substitute here. So you can make it in terms of x only. So a of x is x squared plus 4x times 500 over x squared. So 1x cancel out. So you end up with x squared plus 2000. 4 times 500, 2000 over x. Now let's take a derivative to find the critical value. So 2x. And this one, before you take a derivative, you can change into like that, okay? Then you don't have to use quotient rule. So when you do this on power rule, minus 200 times x on negative 2, so that means over x squared, okay? Set this one equal 0. Now, let's solve for this one. Then 2x equals 200 over x squared. So when you cross multiply, 2x cubed is 200. So x cubed is 100. Hold on. 2x equals 2000 actually, right? 2000, so 2000. So that's a 2000, so that's 1000. So x is a 10. Okay, x is 10. Now, how do you know that one is a minimum value? So you can also do number line test, a prime of x. Okay, so 10. So like 9. Let's talk about domain. X is your domain should be greater than 0, right? Just greater than 0. Yeah, greater than 0. Yeah, you can say just greater than 0. Now, 9 and 11, you can plug it in, right? Into here, okay? You can use calculator and then plug it in, and then you will get negative and positive. So that means going down, going up. So you have a minimum. Okay, minimum surface area. So what is the final answer? What dimension should they use to have a least amount of glass? Then x is a 10, right? So right here is a 10 feet. Okay, and this y value, you plug it in here. 500 over 10 square is a 5. So 5 feet. So 10 by 10 by 5 feet, that's the dimension of the glasses, right? Okay, let's move on. Number 6, and at which point on the graph of y equals root x is closest to the 5, 0. So let's quickly sketch. This is root x graph. Let's say 5, 0 is right here. Somewhere, I don't know, right? Somewhere that one, like that distance, let's say here x. And then that point is on this graph. So instead of y, you can say root x. Okay, y is root x. That's the reason. So what is their distance? Okay, so if you know the 2 point, the distance, let me write down general formula. The distance formula, generally, x2 minus x1 square, y2 minus y1 square. You need to know this one. Okay, so then to do that, so let's say this one, you can say x2 y2 and x1 y1. Okay, you can label like this. So your distance, okay, distance is square root of, so x minus 5 square plus root x minus 0 square. Okay, that's the distance formula. So when you simplify inside, x squared plus 10x plus 25, and root x squared is just x. So x squared minus 9x, when you collect like term, 25. Now, so you need to find out minimum distance, right? So to find out minimum there, you need to find out minimum inside. Okay, let's say small d is x squared minus 9x plus 25. Okay, to find the minimum derivative of that, 2x minus 9. So to find the critical value, you take a derivative and set equals 0. So 2x equals 9. So x is 4.5 when you divide it. Now, how do you know that's a minimum, right? So you can check d prime and 4.5. So you use like 4 or 5 into here. So if you use a 4, that's a negative. Use 5, that's a positive, going down and up, so you have a minimum. Okay, let's talk about domain. Your x value should be positive side, so your domain is just positive. Okay, now, so what is the y coordinate at that time? So if you get 4.5, so your coordinate is 4.5 comma square root 4.5. Okay, you can leave it like that. You don't have to make it like decimal. Okay, let's move on. Now, number 7. Okay, make sure you pause the video, each problems, and then I want to try on your own, and then after that you compare. And then if you don't get it, then you always go back to the video in the beginning of that problem, and then you can listen one more time. Geometry student wants to draw rectangle inscribed and semicircle radius 8. So let's sketch it. Semicircle. And then that student want to draw rectangle inscribed like that. And then one side must be on the semicircle. That's what I did here. And now what is the area of largest rectangle that students can draw? Okay. What they say is radius 8. So this is radius 8. Okay, let's say the dimension for this, let's say, this one is x, let's say, then this one is a y, then this one is a 2x, because it should be double, because that's the center right here. Then you can say area is 2x times y. Okay, I'm talking about area of this rectangle, length times width, so 2x times y. Now, one equation we know using that Pythagorean theorem right here, that triangle, x squared plus y squared equals a squared is 64. Okay. Now I need to isolate y. So y squared equals 64 minus x squared. So y is a square root of 64 minus x squared. So when you put that in, a of x now, 2x and then square root of 64 minus x squared. So I'm gonna take a derivative this one. This one little like little complicated because that's a UV product rule. When I take a derivative this one to find the critical value, I need to use a product rule. So let's go ahead and do that. So when you take a derivative, u prime, so that's just 2 times a v and square root 64 minus x squared plus the other one. I'm going to take a derivative 64 minus x squared to the 1/2 power. So when you take a derivative of that, 1/2 6x minus x squared to the negative 1/2 power rule, but you have to multiply inside chain rule. Hold on, this is 64. So only negative 2x, right? But times also you have to multiply 2x. Okay. So what I'm saying is this is u prime and v, and up to here that's a v prime and u. Okay. So I use a product rule. Little complicated, and then set equals 0, and then let's solve it. So this one of the two cancel out. So when you simplify, 2 square root 64 minus x squared, and now minus, and then you get 2x on the top over square root 64 minus x squared equals 0. Okay, so from there, you move this on the other side, then 2 root 64 minus x squared equals 2x over root 64 minus x squared. So 2 drop it, cancel out. And now when you cross multiply, square root 64 minus x squared times the square root 64 minus x squared, you take out the square root, then 64 minus x squared only, that times x. Okay, so that's nice. Now x squared plus x minus 64 equals 0 once you move everything the other side. And then you can factor. Hold on, actually, no, there's a looks like a little mistake there. Oh, this one x and x, so that one is x squared, right? It's good to find that mistake there. So this one actually, then 64 equals 2x squared, x squared equals 32, right? And then x is a root 32, or you can say 4 times 4 is 16, 16 times 2 is 32, so 4 root 2, okay, 4 root 2. So that's the x value I found. Now, but you have to prove, okay, let's talk about domain first. Then x is of course greater than 0, but less than radius, right? That's your domain. In that domain, I'm gonna prove that one is actually maximum area, right? Largest area. So a prime, and then you put it like 4 root 2, okay? And then you pick any number here, and then you check right here, right? That's a prime. And then you plug it in, then you will see that's a positive and negative. Okay, so going up, going down, so you're gonna have a max. That's the maximum area. So you can justify your answer like that. And then now, what is the area actually then? So then you can plug it in. A equals 2 times 4 root 2 times the square root. I'm using this equation right here. Okay, I'm plugging this x value, the one I found, and 64 minus x squared was 32 anyway, so 32. So 8 root 2 times root 32, right? Root 32 is a 4 root 2. So 32 times 2, so 64. That's your final answer. Okay, that's the maximum area you can have. It doesn't have any dimensions, so you don't have to worry about it. Or you can say unit square. Okay, area unit. Now let's move on. Number 8, two vertical pole. One I cannot see very clear, so here I'm gonna erase a little bit. So here 4 feet high and the other 16 feet high. Stand 15 feet apart on a flat field. So let's draw it. Two pole and they are 16 feet apart. Okay? No, sorry. 15 square feet apart. The height, this is 4 feet and this one 16 feet. Okay? Now, a worker wants to support both poles by running the top from the ground to the top of each post. So that means like they use that support on the ground like that, and then you connect to the post top. Okay, those are rope. Okay, maybe I have to highlight it. So that's the rope, the one highlighted. Now, if the worker wants to stake both ropes on the ground at the same point like that, and then where should the stake be placed to use the least amount of rope? Okay, to use the least amount of that rope, where he need to, the worker need to put the stake. So let's say this on X right here. So you're looking for X actually. And this one is a 15 minus X. And your domain X value so should be greater than 0 and then less than 15. That's your domain. Okay. Now, so what you can do, let's say the total length is using Pythagorean theorem, right? So square root 16 plus x squared right here. That's root 16 plus x squared. And right here, that one is also another Pythagorean theorem. So root 16 squared, so 256 plus 15 minus x squared. Okay, so I'm gonna add up those two lengths. 256 plus 15 minus x squared, like that. So I need to take a derivative of that, and then you need to find out critical value. Okay, let's do that. So when you take a derivative, that's also 1/2 16 plus x squared negative 1/2 times chain rule 2x plus same thing 1/2 256 plus 15 minus x squared negative 1/2 times derivative inside is basically 215 minus x times the negative 1. Okay, that's really long. And then you need to set this one equal 0. Okay, so let's simplify a little bit here. 2 cancel out. So you get x over square root 16 plus x squared. And these 2 cancel. And you have a negative there. So minus 15 minus x over square root of 256 plus 15 minus x squared, like that. And that equals 0, right? That equals 0 means you can say just equal, like that, to solve for x. Now, so then what you need to do, next step, let's square it, okay? Let's square both sides. Let's square both sides to take out the square root sign. And then multiply that, cross multiply. So that means x squared, and then 256 plus 15 minus x squared equals, when you square it, so 15 minus x squared times that one, take out the square root, right? Because you square it, 16 plus x squared, like that. Okay, so I believe you understand so far. Now, what you can do, next step, let's multiply it out, okay? Let's multiply it out. I see something there. Okay, so when you multiply x squared here, so 256 x squared plus x squared times 15 minus x squared, On the right hand side, also when you multiply it out, 16 times 15 minus x square plus x square 15 minus x square. Now I see that this one is the same, so you can cancel. That's nice. And then after that, you have the only this one and this one left. So why don't I divide by 16? So then 16x squared equals 15 minus x squared. Okay, and then what you can do is 16x squared, and then let's void it out. So then x squared minus 30x plus 225, 15 squared, and then 15x squared plus 30x minus 225 equals 0. Now you divide by 15 both every term, then x squared plus 2x minus 15 equals 0, and then you factor it finally. So x plus 5, x minus 3 equals 0, so x is a negative 5 and 3. But negative 5 doesn't make sense for lengths, so only this one. So that one is the dimension I got for x. But you have to show that one is actually minimum, right? Because the least amount of rope. So L prime, you have to check 3. So 3, where you need to put that in? It's a long way. So basically you have to put that in here, okay? So then you can just pick number before and after, and then you will see that's going down, going up, right? So to find the minimum. So that's the justification, and your dimension is a 30 feet from the 4 feet pole. Okay, that's your final answer. Now next one, number 9. An architect is designing a composite window by attaching the semi-circular window on top of rectangular window. You can draw rectangular window and this one semicircle window. So the diameter of the top window is equal to and aligned with the width of the bottom window. The architect wants the perimeter of the composite window to be 18. Okay. Perimeter means the length all the way around, only outside though. Okay, so now, so what dimension should the bottom window be in order to create the composite window largest area? So let's do this way. This radius r, and let's say this one y. Okay. So 18, that's what they gave you here. So that's a perimeter. So how are you gonna say perimeter? So this one, that's a 2y. So you can say 2y plus. Now this one 2r, and this one is semicircle. Semicircle is instead of 2 pi r, half of that, so pi r. Okay, so you can say 2r plus pi r. Okay, that's how you're gonna set up. Now how you gonna find the area? Area is first of all 2ry, right? 2ry. 2ry means this is 2r. 2ry is this area right here, rectangle, plus 1/2 pi r square, right? Semicircle. Now from here you can isolate y. So let's do that. Then 2y equals 18 minus 2r minus pi r. Y is 9 minus r minus 1/2 pi r. Okay. Now let's substitute 2r instead of y. 9 minus r minus 1/2 pi r plus 1/2 pi r square. Okay. So when you distribute 18r minus 2r square minus 2 cancel out, and then pi r square, okay, and plus 1/2 pi r square. So you can this one correct items. So your A is 18r minus 2r square minus pi r square over 2. Okay, Now let's take a derivative. Okay. But before you do that, you can find out dimension. R should be then greater than 0, definitely, right? And then should be less than 18, of course. Now, I'm talking about this on domain. So let's take a derivative. That's 18 minus 4r minus pi r. Okay, you set equal 0 to find out critical value. So here, then 18 equals r you factor out 4 plus pi. So from here, r is 18 over 4 plus pi. Okay, that's the dimension of r. Now you can check that a prime. So 18 over 4 plus pi. So you need to use a calculator for this. And before and after, when you substitute into here, right? Then you will get positive and negative. So you have a maximum area. Okay. So they ask you, that's the justification. They ask you what is the dimension. So that r is that one. So actually this one 2r. So 36, right? Over 4 plus pi. Because double r, right? Twice of that. How are you gonna get y? So from here you can get y. So y is a 9 minus 18 over 4 plus pi minus pi over 2 times r, 18 over 4 plus pi. That's a little confusing, but let's do that. This is 9. So you can have a common denominator, which is 4 plus pi. So 9 times 4 plus pi, so 36 minus 9 plus pi, 9 pi, right? And minus 18 minus 9 pi. So 9 pi cancels out nicely. 36 minus 18 is 18. 18 over 4 plus pi. Okay, that's y value. So that dimension here is 18 over 4 plus pi. Okay, that one is a feet also. So that's the dimension to have a maximum area. Okay, and then I think that's it for this video. So hopefully you get good grade for optimization problem.